All right, everybody, we're getting down to the wire here. Today we got geometric sequences and series. So the first thing is, how do we recognize a geometric sequence? So I'm going to write it formally and I'll explain it. So a geometric sequence is when each term after the first term is obtained by multiplying the preceding term by a constant amount. So basically, you get the next term by multiplying the first term or the term before it by a number. So the same number. So this constant amount right here, this constant amount is fixed. It is non-zero. So you basically just get the next term by multiplying the term before it by the same thing each time. The term, I'm just going to take notes on the side here. So that amount you multiply by, we call it the common ratio. And that common ratio is found by doing A2 over A1. And we know A2 over A1 to be the first and second term. So you just divide them. And that gives you the common ratio. So put that in your notes right there. The formula for the general term for the geometric sequence, another thing, you're going to star this stuff because you're going to need it. So for the nth term, so whatever term of a geometric sequence is going to be a sub n equals a1, which is the first term, times r. R is the common ratio, and r is raised to the n minus 1. And that is your formula. So those are some notes. Just have them. You're going to need them. We're going to use them. All right, so our first example here, write the first 5 terms of the geometric sequence. So they give us the first term. You're definitely going to need your calculator for this one. It doesn't have to be graphing. Anything works. I'm just going to hold mine off to the side. So the first term is 24. So that is A1. So how do we get A2? You take 24 and you multiply it by the common ratio, which is 1/3, which is 8. So then how do you get A3? You take 8. You multiply it by 1/3. You get 8 over 3. How do you get A4? You take 8 over 3. You multiply it by 1 over 3. You get 8 over 9. And finally, how do you get A5? You take 8 over 9. You multiply it by 1/3. And then you get 8 over 27. So your first 5 terms are 24, 8, 8/3, 8/9, 8 over 27. Now, if you notice, the one thing that was the same, the 1/3, the 1/3, the 1/3, that stayed the same. 1/3, 1/3, 1/3, 1/3. That's my common ratio. I never changed it. The only thing I was changing was to find the next term, I kept using the term before it. Notice I didn't use 24 the whole time. Once I got 8, I used 8. Once I got 8 over 3, I used 8 over 3. That is your first example. All right, example 2. Write the first 5 terms, except now they're not giving me the common ratio. So I have it written as an equation here, and I got to be able to find the common ratio from it. So the common ratio, or my r, is this -3. So -3 equals r. Because remember, I'm going to do a note over here. A sub n minus 1 equals the term before. So it's actually the same thing we just did, just written in a little bit different way. So I'm just going to, take A1, which is 10, multiply it by -3. Same thing. -30. I'm sorry, that's A2. A3. negative 30 times negative 3, 90. A4, 90 times negative 3, negative 270. And A5, negative 270 times negative 3 equals 810, I believe. Yes, 810. So your first 5 terms are 10, negative 30, 90, negative 270, 810. So the same one as the other one. The only kicker here is that they write it out a little different, and they say, oh, you're doing negative 3 times the term before it, which is a sub n minus 1. Example 3. So this is where we're going to use that formula that we wrote on the first slide. That was a sub n equals a1 times r to the n minus 1. Because I don't want the first 5 terms, I want the 12th, and I don't want you writing out all 12 terms. So what you're going to do is you're going to plug everything in. So a sub 12 equals a1, which is the first term, which is 4, times the common ratio, which is negative 2. And we're going to raise that to the n minus 1, which is 12 minus 1. So this is a12 equals 4 times negative 2 to the 11th. Now, this isn't, common mistake, this is not negative 8 to the 11th. You have to do in your calculator, negative 2 to the 11th times 4. And that gives you the answer. Do this part first. It's not, you can't do 4 times negative 2. You got to do the exponent first. So the answer is negative 8,192. And that is example 3. All right, write the formula for the general term of the geometric sequence. Use that formula to find a sub 7. So they don't give us a formula. They don't give us anything but the sequence. So we got to do all the work ourselves. So the first thing you should notice is that 12 is our A1. The next thing we got to do is figure out R. So R is the common ratio. So what's happening as we go from 12 to 6 to 3 over 2? So how do you get from 12 to 6? You're not dividing it by 2, you're multiplying by 1/2. So R is your 1/2. So now all you do is you just plug right into that we've been using. So your general formula is AN equals A1, which is 12, times R, which is 1/2, to the n minus 1. So that's going to be your general formula. And then I'm just going to close that off. General formula. And then they just want you to use that to find a sub 7. So you're going to say a7 equals 12 times 1/2, 7 minus 1. 12 times 1/2 to the 6th. Grab my calculator here. 1/2. Oops. Always use parentheses. Yeah. 1/2 to the 6th times 12. Math. Enter, enter. Nice little fraction. You're going to get 3 over 16. And you are done with that one. So that is example 4. All right. So let's keep going here. It says, how do we find the sum of the terms in a geometric sequence? So the sum, you're adding them up. So your sum formula, so we're going to start this off because you're going to need it. This is your sum formula. Sn equals A1 times 1 minus Rn over 1 minus R. So the same kind of things we've been using. Just a big thing is if R is a number between -1 and 1, so like that, the term the term approaches 0 as n gets larger. So basically, as n gets larger, the term approaches 0. We're not really talking about infinite sequences in this video. We're just kind of talking about finite, so things we can find. So this is our formula we're going to use, and it's just a little thing we should know. Make sure you copy that down. What is the difference between a sequence and a series? So a sequence is an ordered list of numbers. A series is the sum of a list of numbers. A list of numbers. So just some notes that I want you to have. And we're going to keep going. Just got 2 more questions, and then we are done for the day. 2 more examples before everyone does their MyLab. All right. Find the sum of the first 12 terms of the geometric sequence. So we're going to use that formula that we just wrote down on the last slide. So I'm just going to rewrite it. S sub n equals A1 times 1 minus Rn over 1 minus R. Before the assessment, I will give you guys a formula sheet that has everything on it, but you should have everything from the notes. So now we're just going to kind of plug in. A1 is 3. What is R? What is R? We should all recognize that R is 2. Why? Because you go from 3 to 6 to 12 to 24. You're finding you're doubling. So it's 2, and n should be 12. So A1, which is 3, parentheses 1 minus R, which is 2 to the 12th, over 1 minus 2. Grab my calculator. Notice I am respecting all parentheses. I do everything in order. I don't skimp. I do it all in order, and you get 12,285. So that is the sum. That's going to be the sum of the first 12 terms. So that is example 5. All right, last example here. Find the indicated sum using the formula. So this is all the same thing, same formula. They just give everything to us in sigma notation. So I'm just going to kind of jot down my formula over here. Sn equals A1, 1 minus Rn over 1 minus R. So we got to do a little work first. First of all, what is our first term? A1. Well, we don't know what the first term is, so let's use the sum and get it. So 4 times negative 3 to the first, negative 12 is our A1. My R. So this is where we need to know is what's happening to each term. The R is right in here. The R is going to be that negative 3. And n is 7. And how do I know 7? Because right here the upper limit says 7. So now I just plug everything right into the formula. So right into the formula, S sub 7 is A1, which is negative 12 times 1 minus R, which is negative 3 to the 7th, all over 1 minus negative 3. Now, when I do this, I'm going to show you how I type it into the calculator. Notice when I type it into the calculator here, I'll put my calculator over here. I'm going to negative 12 on the outside, 1 minus negative 3 to the 7th. Notice how I don't make this 4, because it's not 4 to the 7th. It's negative 3 to the 7th, and then 1 minus that. I'm going to hit enter. Now I'm going to divide by 1 minus negative 3, and I'm going to get negative 6, 5, 6, 4. That concludes the video for 10.3, geometric sequences. We didn't do infinite, we just did finite. Now you can work on the MyLab.